Okay, number 28, they want us to find the measure of arc DAC. Maybe I should hit this with a little bit of highlighter. They want this whole thing right there. Okay. All right. So actually, if I knew this arc AD and this arc AC, I could add them together to get this arc DAC, right? I think I can find these because I know I've got a tangent and a secant intersecting outside the circle. And when they do that, they form an angle, in this case 65 degrees. They form an angle that's equal to 1/2 the difference in the two arcs that they intercept. 1/2 times 96x minus 2 minus. Now here, when you're subtracting something like this, you got to make sure you put in those parentheses. You're subtracting a quantity. And so you got to distribute a -1 there, right, to get rid of those grouping symbols. Hopefully you remember that from Algebra 1. 65 equals, and if you want, another thing you can do, save a step here and multiply this whole equation by 2 to get rid of that 1/2. 2 times 65 is 130. The 1/2 disappears, and we're left with 96x minus 2 minus, I'm going to distribute this -1, minus 31x. What's -1 times -2? That becomes +2, okay? Because you're subtracting a quantity that is 2 less than 31x, so it must be a little more than that, right? You have to add that 2 back in. All right, 130 equals 96x minus 31x, leaves me with 65x, and -2 plus 2, 0. Good. Subtract, divide both sides by 65, and I think we get 2 equals x. Good. All right, let's look at 29 here. Here we've got a tangent intersecting a secant at the point of tangency. And when that happens, it intercepts and it forms an arc that's equal to 1/2 the measure of the arc that it intercepts. And they want us to find EFG, this angle in here. So just that angle. Good. So we know it's going to equal 1/2 the measure of angle EFG is going to equal 1/2 the measure of arc EF. No, we don't know that, do we? Well, we do know that 2x plus 28 is the angle that is formed. That's EFG. And we know it's going to equal 1/2 of, if this arc is 22x plus 18, then this arc is 360 minus that quantity. So it's going to be equal to 1/2 of 360 minus this quantity, 22x plus 18. Good. So we get 2x plus 28 equals, if you want, you could multiply both sides by 2. You want to get rid of that 1/2? I think that would be handy. That'd probably be a good way to do this. We'll distribute this 2 here. And we get 4x plus 56 equals, the 1/2 goes away. I get 360 minus 22x. Don't forget, we got to distribute a -1 here. What's -1 times +18? -18. Good. So we get 4x plus 56 equals, what's 360 minus 18? I think that gives me 342 minus 22x. Good. We can clean this up by adding 22x to both sides while we subtract 56 from both sides. Right, I get 26x equals 342 minus 56 gives me 286, I believe. And if we divide both sides by 26, I think we're going to get x equals, hold on, you don't trust me on that, do you? 342 minus 56 divided by 26. And we get x equals 11. Good. All right, number 30, they want us to find the measure of angle TUV, this angle here, okay? So when we have two tangents intersecting outside the circle, they form an angle that's equal to, in this case, 11x plus 6, equals 1/2 the difference in the two arcs that they intercept. So 1/2 of 42x minus 18x. Good. If you want, blast out the 1/2 by multiplying both sides by 2. I'll distribute this 2 here. I get 22x plus 12 equals 42x minus 18x, which simplifies to, that would be 24x. So 22x plus 12 equals 24x. And if we subtract 22x from both sides, I think you're going to find that 12 equals 2x and 6 equals x. Good. Let's try the same thing here, except this time we don't have tangents. We've got two secants intersecting outside the circle. Concept is the same, right? They want us to find, oh, hold on, Mr. Rogers. You almost got us one wrong on the practice final, right? Oh my goodness, look at this. Never trust your math teacher. I did not fully answer the last 3 problems. Let's go back and do it. If we are looking for the measure of arc DAC here, we've got to plug in our 2 for x, and we get 96 times 2 is 192 minus 2 is, that's 190 degrees. And this arc in here is going to be 31 times 2 is 62 minus 2 is going to give me 60 degrees. So the measure of arc DAC is going to be the sum of those two. It's going to be 250 degrees. Good. All right. And now they want us to find this angle. We found x. Silly me. 2 times 11 is 22 plus 28 is going to give me 50 degrees. Good. And then over here, if x equals 6, then this is 11 times 6 is 66 plus 6 is 72 degrees. All right. All right, everything's all set. Let's do the same thing here. We've got 2 secants intersecting outside the circle, and they're going to form an angle, 3x plus 8. That's equal to half the difference in the 2 arcs they intercept. So 1/2 of 13x minus 10 minus 44. No need for grouping symbols or distributing a -1 there because I'm not subtracting a binomial. I'm just subtracting just a monomial. I can still get rid of that 1/2 by multiplying both sides by 2. And when I distribute that 2, I get 6x plus 16 equals 13x minus 10 minus 44 is minus 54. Good. All right, I'm going to add 54 to both sides while I subtract 6x from both sides. And I'm going to get 70 equals 7x. 10 equals x. All right, we're done, right? Mr. Rogers, come on. You know you got to plug it back in. 3 times 10 is 30 plus 8 gives us 38 degrees. Is that what they wanted? Angle SUD. Good. Okay, this time, hey, I'm going to go ahead and highlight all the things they want us to find so I won't forget to plug back in and do it when we're done. They want BD. Over here they want UV, that segment there. Here they want UV. They want that segment there. And here they want DB. Okay, so remind me if I get ahead of myself. All right, they want us to find BD. We've got chords intersecting inside the circle. We know the product of the segments are going to be equal. We already did a problem like this earlier, a little more complicated version than this. So here, 27 times 20 is going to equal 3x times 5x. Okay. Now when I multiply 27 times 20, I get 540, right? And when I multiply 3x times 5x, be careful here, I get 3 times 5 is 15. And x times x is x squared. Okay, I can divide both sides by 15, and I get, let's see, what is 540 divided by 15? I know that's going to be a nice number. I get 36 equals x squared. Oh, beautiful. Go ahead and swish and flick. You're going to get 6 for x, and therefore 5 times x is 30, and 3 times x is 18. And therefore BD equals the sum of the two, which is 48. Good. Let's do the same thing here, except this time we're intersecting outside the circle. So we know that the external segment times the entire secant will always equal this external segment times this entire secant. So the external segment is 4. The entire secant here is 4 plus 2 is 6. Good. Here, the external segment is x minus 7, but the entire secant is x minus 7 plus x minus 5, which is 2x minus 12. Good. Okay, so the external segment 4 times the entire secant 6 should equal the other external segment x minus 7 times the entire secant 2x minus 12. Good. So I get 24 equals, can I go ahead and FOIL this? Do some boss level distribution on this thing. Good. I get 24 equals x times 2x is 2x squared. X times negative 12 is negative 12x. Negative 7 times 2x is negative 14x. And negative 7 times negative 12 is positive 84. Good. Let's clean it up a little bit. We'll subtract 24 from both sides. I get 0 equals 2x squared minus 26x plus 60. Good. Now we don't have to factor by grouping here because we should go for the greatest common factor first, right? Can we go ahead and factor out that 2? What are we left with? After we divide each of these terms by 2, I'm left with x squared minus 13x plus 30. Okay, so now a is 1, and we can do our 6-piece puzzle, and we can say x and x. We're multiplying to a positive number, so both of these signs are going to be the same. They're going to be either both positive or both negative. In order to add to a negative number, they must both be negative. Good. All right, two numbers that multiply to 30 and add to 13. How about 10 and 3? How's that sound? Looks good. And if you're at all unsure of your factoring, you can go ahead and FOIL that back out and just confirm that you get back to the same trinomial you started with. So here we've got, if x minus 10, if 0 equals 2 times this, one of these factors must be 0. So I can get x minus 10 equals 0, or x minus 3 equals 0. I get x equals 10, or x equals 3. In this case, let's see if each of these is going to be valid. We might have two cases here, or one of these might be invalid when we plug it back in, because remember they want us to find UV. So 10 minus 7 here leaves us with 3, and 10 minus 5 leaves us with 5. I think I have to reject this root, because if I plugged it in here, 3 minus 7 would give me an external segment of negative 4. So I have to reject this root, okay? Even though it came out to be positive, when I put it in my problem, it gives me geometry that doesn't make sense. So that gets rejected. All right, so what's UV? 10 minus 7 is 3. Good. All right, can we do the same thing for 34 here? External segment times the whole secant. How long is the secant VT? 3x plus 7x gives me 10x, right? How long is this secant here? 10 plus 17 gives me 27. So I can say the external segment times the whole secant, 10 times 27, is going to equal this external segment, 3x, times the whole secant, 10x. Good. And I get 270 equals 3 times 10 is 30. X times x is x squared. Good. And I'll divide both sides by 30. And I get 9 equals x squared. Something tells me that 3 equals x. Okay, they want UV. So 3 times 3 is 9. And of course, right here, I actually got x equals plus or minus 3, right? But I threw out the negative 3 because I knew it was going to give us a nonsensical answer in geometry. Good, let's try 35 here. We're back to the chords intersecting inside the circle, and we know the products of the segments are going to be equal. I got 6 times 10 should equal 4x times x plus 2. okay? And I can say 60 equals, let's distribute that 4x. I get 4x squared plus 8x. Let's go ahead and subtract 60 from both sides. I get 0 equals 4x squared plus 8x minus 60. I know what you're thinking. Oh, we got to factor by grouping. No, we don't. We could go for the GCF, right? Could we factor this into? I think we can factor a 4 out of each of those terms. And when we divide 4x squared by 4, we're left with x squared. When we divide 8x by 4, we're left with 2x. 2x, excuse me. And negative 60 divided by 4, we're left with negative 15. Good. Now could we drop our 6-piece puzzle on this nice trinomial because a equals 1? We know we're going to have x times x. We know we're going to have opposite signs because we multiply at some point to a negative number. And we know we need two numbers that multiply to negative 15 and add to positive 2. If they're going to add to positive 2, the larger of the two numbers is going to have to be the positive one. So I'm thinking 5 and 3. How's that look? And I know I can reject this. At least I think I can, looking at the geometry. Yes, I can't end up with a negative value for x because that would screw things up there. So I know that I'm going to say x minus 3 equals 0 and x equals 3. Good. Okay, so here, 4 times 3 gives me 12. X plus 2 is 3 plus 2 is 5. When I add those together to get BD, I find DB is 17. Back here I said UV was 9. Good. Okay, identify the center and radius of each. Here I've got a circle. 6y equals 4x minus x squared minus y squared. That doesn't look like my standard form. I want it in my standard form. X minus h squared plus y minus k squared equals r squared. Not a bad idea to memorize that, but if you don't remember it, you can always draw yourself a sketch and rederive it using Pythagorean theorem, because that's where it comes from, right? That's a squared plus b squared equals c squared for any given point on the circle. If you make a triangle between that point, the center of the circle, and form a right angle with it. So to get it into standard form, let's go ahead and rearrange this thing. This thing is a pretty big mess. I'm going to say negative x squared plus 4x. I'm going to leave myself a little bit of space because I know I've got to do that completing the square trick. I've got to add something in here. And then I'm going to go to my y, negative y squared plus 6y. We'll leave a little bit of space. And I'm going to say that equals 0. Okay? Now another thing you could do, actually, and this might be a little handier, if you want to get rid of these negatives, you could add x squared to both sides, add y squared to both sides, and subtract 4x from both sides. Okay? And that might end up looking a little neater. Okay, so I'll end up with x squared minus 4x, leave some space, y squared plus 6y. Notice the 6y is already on the other side. In fact, I made a mistake there. Wow, did you guys catch that? I totally made a mistake there. Space equals 0. Okay, so we're just trying to get these things all on one side, and if you don't want to deal with the negatives, then kick them over to the other side of the equation and make them positives, right? So let's go ahead and see what we can do here. After we added x squared and y squared and subtracted 4x, we were left with nothing on the other side. I'd love to get this into some by perfect square trinomial and this into a perfect square trinomial so we can go into standard form. So I'm going to say, what is b? Negative 4. What's b over 2? Negative 2. What's b over 2? Squared. It's going to give me 4. So that's what I have to add to both sides to make that a perfect square trinomial. And then it becomes x minus 2 squared. Remember, all you got to do is take your b over 2, plug it in there. Okay, let's do the same thing with the y squared plus 6y. What's b over here? It's 6. What's b over 2? 3. What's b over 2 squared? Gives me 9. So I'll add 9 to both sides. And that turns this into y plus 3 squared. So we get x minus 2 squared plus y plus 3 squared equals 13. Okay, so identify the center and the radius. What's h? X minus h. H is 2. What's k? Y minus k. That must be, k must be negative 3. And r is the square root of 13. Okay. All right, I can't set my compass to the square root of 13, so I'm going to go ahead and ask the calculator, what is that in decimal? Approximately equal to 3.6. Good. So the center of my circle is at over 2, down 3. There's my center. And my radius is 3.6. And try to just line it up with 3.6 units on my graph, approximately. And here we go. Spin it and win it. See if I can get this to go all the way around. All right, there's my circle. Not too bad. Let's see if we can try one more. Okay, on this one, fortunately I got the y squared and the x squareds are positive. So let's keep them, let's add 4x to both sides and add 6y to both sides. Excuse me. So I'm going to get x squared plus 4x. And then I'm going to get y squared plus 6y equals negative 12. Okay, what do I have here? What's b? 4. What's b over 2? 2. That's what's going to go into my binomial. But b over 2 squared is what I have to add to both sides. So 2 squared is 4. I've got to add 4 to both sides to make that perfect square trinomial. And it becomes x plus 2 squared. This guy goes in there. Good, let's do the same thing for our y terms. Oops, I didn't leave myself any room there. B equals 6. B over 2 equals 3. That's going to go in my binomial. And b over 2 squared equals 9. I'm going to add 9 to both sides. And this term here becomes y plus 3 squared. Remember, b over 2 just pops in there. Let's clean it all up. X plus 2 squared plus y plus 3 squared equals negative 12 plus 4 plus 9. 9 and 4 is 13. So this is going to be positive 1. Okay? All right, so r squared equals 1. All right, what's my radius? R equals 1. Good. What's h? If this is x minus h, h must be negative 2. What's k? If this is y minus k, then k must be negative 3. So the center of my circle is at negative 2, negative 3, and it has a radius of 1, which I am not going to set my compass to. That is probably not feasible. Tiny little circle like that. Okay, next one here. They want us to, with this information, write the equation of this circle. The ends of the diameter are 5, 1, and negative 9, negative 3. Now, if you want to take the shortcut here, you can find h and k by finding the midpoint of these 2 points. Midpoint equals x1 plus x2, 5, plus negative 9 over 2, and y1 plus y2 over 2, 1 minus 3 over 2. Okay, so the midpoint here is going to be 5 minus 9 is negative 4 over 2. It's negative 2. And 1 minus 3 is negative 2 over 2 is negative 1. So h is negative 2. K is negative 1. Good. All right, so how are we going to find the radius of this? We need our radius. Well, the radius is the distance from the center to either of these points. So if you wanted to call this x1, y1, you could call this guy over here x2, y2, and plug them into the distance formula, right? Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So in this case, we're going to get x2 minus x1, 5 minus negative 2 is 5 plus 2. And y2 minus y1, 1 minus negative 1 is the same as 1 plus 1, which is 2. So the distance from the center of the circle to the edge is going to be the square root of 49 plus 4, square root of 53. So we can go ahead and write the equation now. X minus h, x minus negative 2 is x plus 2 squared, plus y minus k, y minus negative 1 is y plus 1 squared, equals r squared. Okay? So if the distance from the center to the edge was the square root of 53, that is the radius, isn't it? And then r squared would be the square root of 53 squared, which would be 53. Good. All right, could we do the same thing for 39? And if you want, I really do not want to discourage you from graphing these. It'll definitely help you feel better about your answer. So if you've got graph paper, go ahead and graph those. Not a bad idea. Let's do the same thing with 39. Our midpoint here is going to be 16 plus 2 over 2 and negative 8 plus 6 over 2. So the midpoint of this diameter is going to be 18 over 2, 9. Negative 8 plus 6 is negative 2 over 2 is negative 1. Good. All right, if we want, we could call this, we're going to work with the positive numbers, x2, y2, and x1, y1. We'll plug them into the distance formula. And we're going to get the square root of 2 minus 9 squared plus 6 minus negative 1, or 6 plus 1 squared. Good. And when we clean that up, we're going to get 2 minus 9 gives me negative 7 squared is going to be 49. And 6 plus 1 is 7 squared is another 49. So I get the square root of 98. Good. And we found that x1, y1 was also h and k conveniently, right? So could we write this as x minus h squared plus y minus k. Remember, y minus negative 1 is y plus 1 equals the square root of 98 squared. Don't forget that was our radius that we found. Square root of 98 squared is just 98. Good. All right, solve each triangle. Here we've got triangle DEF. Now we don't know if this is a right triangle or not, so we can't use our trig ratios, but the first thing you should always do is just go ahead and draw yourself a triangle. DEF, angle F is 36.3 degrees. Okay, if you guys remember one thing from trigonometry, please remember that if this is angle D, this is side D. And if this is angle F, then across the triangle is side F. And if this is angle E, this is side E. Okay, so side F is 24 centimeters, right? Side E is 11 centimeters. And we've got to solve the triangle. What do we want to go after first? I say let's go after an angle. How about we go after angle E? And to do this, I want to use the law of sines first, right? So I could say the sine of angle F over side F is going to equal the sine of angle E over side E, which is going to equal the sine of angle D over side D. Okay, we're going to have a nice proportion to work with when we're done with this. Sine of angle F is 36. Angle F is 36.3 degrees. So I can take the sine of that, divide it by side F, which is 24, and I should get the sine of angle E over side E, which is 11. So you set these up, and if you end up with two unknowns, then you know you have to go to the law of cosines. If you end up with one unknown, you're good to go. Cross products. 11 times sine of 36.3 equals 24 times the sine of angle E. Good. Let's solve that for angle E by dividing both sides by 24. Okay, those will cancel. and I'll get this is the sine of angle E. Or I could say the measure of angle E is the inverse sine of that quantity, 11 times the sine of 36.3 over 24. Okay, because remember, when we're looking for an angle, we're going to use the inverse sine. We've got it all set up and ready to go. Now we can put it in our calculator and say, second function, sine 11 times the sine of 36.3. Close your parentheses there so you don't get in trouble. Divided by 24. If you want, you can close that last parentheses. The measure of angle E equals 15 point to the nearest tenth, 7 degrees. Good. All right, if this is 15.7 degrees, I'm missing an angle. What's that angle D? Well, I could say 180 minus 15.7 minus 36.3 will leave me with this other angle, 128 degrees. Okay? Is it a problem that my triangle is obviously not an obtuse triangle? No, not a big deal. We can just keep working on it. All we have left is this side D here, right? So let's go ahead and see if we can solve that. How are we going to do it? We're going to have to use the law of sines one more time. Let's go ahead and say the sine of 128 degrees over D is going to equal, to minimize any rounding issues, let's go back to the original information we were given. The sine of 36.3 degrees over 24. Good. And our cross products here are going to be 24 times the sine of 128 equals D times the sine of 36.3 degrees. Okay? And this time it's one less step because we are not looking for an angle. We don't have to use the inverse trig function. We're going to divide both sides by the sine of 36.3 degrees. Those cancel, and it's all solved for D. It's ready to go. Let's go ahead and say 24 times the sine of 128. Let's close our parentheses there and divide that by the sine of 36.3. If you want, you can close that last parentheses, and you get 31.9 equals D. Do we have the entire triangle? Indeed we do. Okay, another one here, number 41. Again, we've got some triangle D, E, F. Okay, angle E is 23.8 degrees. The measure of angle F is 37.2 degrees. Okay, and side E is 14 centimeters. Can we solve the triangle? Okay, well, why don't we go after side F first? Because I can see I've got enough information with these two angles to start with a law of sines. I can say, law of sines says, the sine of angle E, 23.8 degrees, over 14, should equal the sine of angle F, which is 37.2 degrees, over side F. Good. Set it up. If you've got one unknown, you're good to go. If you have two unknowns, you know you've got to either look at your information again or use the law of cosines. So we get F times the sine of 23.8 degrees equals 14 times the sine of 37.2 degrees. Those are my cross products, right? And we'll just divide both sides by the sine of 23.8. And those cancel, and you're all set to go. That is solved for F, and you can grab your calculator. 14 times sine 37.2 divided by sine 23.8. And I get F is 20 point, they wanted us to round to the nearest tenth, 20.97. We're going to round it to 21.0. That'd be the nearest tenth. Okay, so F is 21.0. What do I have left to find? I got to find D. Oh, an angle D. Angle D is the low-hanging fruit. Who wants it? triangle sum theorem helps us find angle D. 180 minus 23.8 minus 37.2 leaves us with 119 degrees. Good. Because now we can use the law of sines one more time to find D. We can say the sine of 119 degrees over D equals, now to avoid any rounding errors, let's not go with F, let's go back to the original information. Let's use this pair right here. The sine of 23.8 over 14. Good. What are my cross products going to be? 14 times the sine of 119 equals D times the sine of 23.8. Okay, and I can divide both sides by the sine of 23.8 to solve for D. Those will cancel. We're all solved for D. Let's go ahead and plug it in. 14 times sine of 119, close those parentheses, divided by the sine of 23.8. Good. And I get 30.3 equals D. Do we have the whole triangle? In fact, we do. All right, number 42 in triangle PQR. Q equals 28, R equals 30, and P equals 10. Notice we have no angles. If you have no angles, you have the condition known as side, side, side. That's what we have. And in that particular condition, you've got to use the law of cosines. If you forget and you're optimistic and you want to try the law of sines, go ahead. You can set it up, but you'll have one too many unknowns. And then you're going to have to go into the law of cosines. So let's take a look at our triangle here, PQR. That's angle P. That's angle Q. That's angle R. Side Q here is 28. Side R over here is 30. And side P over here is 10. Good. All right, so let's go ahead and solve for one of the angles. And I'm going to tell you, I think I've told you this before, when you use the law of cosines and you find the first angle, you can make your life a lot easier if you start with the largest angle, because it'll eliminate any problems with ambiguity in the law of sines in the next step. If any one of these angles is going to be obtuse, which one is it? It would have to be the largest angle. It would have to be angle R. So let's go after angle R first. I've got my law of cosines. Something squared equals something squared plus something squared minus 2 times something times the cosine of something. Do you remember what goes in there? Well, if we're going after an angle, the angle goes all the way over on the right side of the equation, cosine of angle R. Okay? On the other side of the equation goes the side that goes with angle R. So R squared goes over here, 30 squared. Okay? And in between, you just put in the other two sides. Q squared plus P squared minus 2 times Q times P times the cosine of R. That's it. Okay? So if you want, you could write this out in terms of just the variables. R squared equals Q squared plus P squared minus 2 times Q times P times the cosine of angle R. I start with the ends and I work my way in. If I've got angle R on this side, I bookend the equation with side R on this side, and the other sides are the ones that go in between. Okay, so I get 30 squared is 900. 28 squared is, what's that? I should remember that. 784. Plus 10 squared is 100. Minus 2 times 28 is 56 times 10 is 560 times the cosine of angle R. Good. All right, let's clean this up. 784 plus 100 is 884 minus 560 times the cosine of angle R. Okay. Now, don't forget you can't combine these. They're not like terms. This one is married to the cosine of angle R, right? But I can subtract 884 from both sides. And I'm left with 16 equals negative 560 times the cosine of angle R. And I'll divide both sides by negative 560. And I get that equals the cosine of angle R. Or the measure of angle R is the inverse cosine of negative 16/560ths. Okay, I just brought that negative into the numerator. So let's go ahead and solve for that. Negative 16 divided by 560. And notice, because our cosine was negative, our angle is slightly obtuse. Okay, so my instincts were good going after that largest angle. If this is 91.6, good. Now I know none of the other angles can possibly be obtuse. So I can go ahead and use the law of sines on them and not worry about the ambiguous case. I can say the sine of 91.6 over 30. The sine of angle R over side R should equal the sine of angle, shall we go after Q next? Sine of angle Q over side Q, 28. Good. My cross products here are going to be 28, I am going to run out of room on this, 28 times the sine of 91.6 should equal 30 times the sine of angle Q. Okay, those are our cross products. And we'll divide both sides by 30. And we've got it solved for the sine of angle Q. So I could say that the measure of angle Q is an angle whose sine, we'll use that inverse sine, is 28 times the sine of 91.6 over 30. Good. And now we're all set to just crank it out. Inverse sine, 28 times the sine of 91.6. Close those parentheses. Divided by 30. Close your last parentheses. And we get the measure of angle Q is 68.9 degrees. All right. That's 68.9 degrees. How do we find the last bit of information? Oops, excuse me, I wrote that in the wrong place. Holy cow. It's been a long test. I'm getting burnt out. Angle Q is 68.9 degrees. All right. So angle P is going to be, we'll just use triangle sum theorem, 180 minus 68.9 minus 91.6 gives me 19.5 degrees. Good. That triangle is solved. Shall we try one more? Okay, we have one final triangle to slay. Triangle FDE. Let's go ahead and just sketch it out. I can already tell I'm going to need the law of cosines. It'll be more apparent once we sketch it. So let's call this FDE. Angle F is 88 degrees. Side D is 30. And so that's side D. And side E is 29. Good. Why don't we go after side F first? Okay. I know I'm going to have to use the law of cosines. I can't use law of sines because if I try to, if I said sine of 88 over F equals sine of D over 30, you can see I've already got two unknowns in there. So since I'm going after side F, let's write it like that. F squared. Okay, I'm going to put F on the left because I know there's only one place in the law of cosines for an angle, and it has to be this angle I'm using, so it's got to go all the way over here, the cosine of angle F, right? And in between, we're going to put the other two sides. F squared equals D squared plus E squared minus 2 times D times E times the cosine of angle F. Okay? So again, we had only one angle. We know in order to use the law of cosines and not end up with too many unknowns, that's the angle I'm going to have to use. It's got to go in there. And that means I'll be looking for side F over here. So we get F squared equals, what's D squared? 30 squared plus 29 squared minus 2 times 30 times 29 times the cosine of 88 degrees. Good. I can crank all of this out on the right side, right? Let's try it. 30 squared is 900, plus 29 squared is, what's 29 squared? 841. Minus 2 times 30 times 29 times cosine of 88. That didn't come out to what I expected. Oh no, that does make sense. That does make sense. So minus 60.7. Okay. Now, if you want, you can crank this out. You know, if you want to be more confident of your numbers, you can say 900 plus 841 minus 2 times 30 is 60 times 29. You can say minus 1,740 times the cosine of 88 if you want, and then multiply that by the cosine of 88. And you can see, in fact, you do get that. So that all checks out. F squared equals 900 plus 841 minus 60.7. Syntax error because I put in a parentheses where none was required. F squared equals 1,680.3. How do I find F now? I'm going to take the square root of both sides. I get F equals 40.99. We'll round that up to 41.0. Good. So if F is 41.0, now the good news with the law of cosines is if you're solving a triangle with it, you will have to use it at most once. The second time, when you're looking for the next piece of information, you can use the law of sines. So I could say the sine of 88 over 41 will equal, which angle do you want to go after next? D. You can pick either one, sine of angle D over side D. Okay, and we can solve this for angle D. Our cross products are going to be 30 times the sine of 88 equals 41 times the sine of angle D. And we'll divide both sides by 41. So the sine of angle D is this. Could I rewrite that and say the measure of angle D will be the inverse sine of that same quantity, right? Sine of 88 over 41. And it's all set, ready to punch into the calculator. If the sine of angle D equals that, then angle D is an angle whose sine is this. And I can say inverse sine, 30 times sine of 88, close those parentheses, divided by 41, and we get 46.99. Sounds like 47.0 to me, to the nearest tenth. And now angle E, how do we get it? All we have to do is triangle sum theorem now. 180 minus 88 minus 47. We get 45 degrees. Did we solve the whole triangle? Yes, we did. There we go. Those are all 43 questions from the practice final. I hope you guys found it helpful, and I hope that you appreciate not having to actually take the final, hoping practice was enough for you. And take it easy.